Hello guys, welcome back to today's session. Previously, we were discussing the types of proximity sensor, and I believe last time we discussed the photoelectric sensor, their working and their applications. For today's topic, we are going to discuss the ultrasonic proximity sensing and the sensors, how they are constructed, their working, wiring, and their various application in an industrial environment. So, without further ado, let's begin. So just like any other proximity sensor, they are available in a wide variety of shape depending on the use case scenario. If the object where this sensor needs to be fitted is hollow, then probably this is the best shape to use. In other cases, where it is needed to be mounted onto a flat surface and detect the incoming objects onto a conveyor or in a similar scenario, maybe these are preferable. So, depending on the use case scenario, they are available in a variety of shape and different sizes. So, how they work is that they are pretty much very similar to the optical based photoelectric sensor. And just like a photoelectric sensor, they are available in three different technologies. Uh, Number one is the through beam technology, as you can see here, right? So we have in this case two separate units. One is the transmitter, which will emit the sonic waves cyclically in a repeated manner. Now, based on the object presence, this wave will either be received or not received by the receiver. So, in the through beam technology, this receiver is a separate unit. So, when there is no object, the cyclical sonic waves, the acoustic waves, will be received by the receiver. And when there is an object, the receiver will not receive any waves. So this is a through beam technology. In the retroreflective technology, there is a reflective, smooth, shiny surface that will reflect back the incoming sonic waves. And the receiver is also housed in the same unit. So this is a transmitter plus receiver. So in case of an object, the receiver, the time of flight will change, that is, the internal circuitry of the sensor will determine that the waves bouncing back from an object is the different because of the time of flight of the received waves. And the last one is the direct reflection method. So in which case the object will directly repel back the incoming acoustic waves to the receiver unit housed in the signal unit. So above you can see is the range of the ultrasonic proximity sensors, and the formula is the time of flight divided by 2 into speed of sound. And using this formula, you can calculate the range of the reflecting back of the acoustic waves. And use this formula as well as the prior knowledge of the size of the vessel to determine the amount of material present. I hope this makes sense. If it doesn't, then it will be clear when we discuss the applications. Just like all other proximity sensor, brown wire is always going to be L positive, blue wire is always going to be L negative, and the other wires, which will be black and white, are the signal wires. So in this particular sensor, the black wire will carry an analog signal, which can be a 0 to 10 volt signal. So as you can see that it will generate, the black will generate a PNP positive signal depending on the time of flight distance between the object. The white wire will at a set point generate a specific command signal which will be used to trigger a relay or an actuator. So this is the working of a particular ultrasonic proximity sensor. Now let us discuss some of the applications of these type of sensors. The most common application you will find for these sensors is the anti-collision. You will find these type of sensors in all sorts of vehicles, and they are mounted there because they are reliable and they are not obstructed by the visual properties. In the second case scenario, you will see that these sensors are being used to detect the breakage in this film. So this senses any breaks or defects in the film, cracks, boards, whatsoever. Now, in this case, in this application, you will see that these sensors are being used to stop the car at its particular operational point. So they are being used to position any object. They are used for level measurement. Now, this is also a most common application for this type of sensor in an industrial environment. They can be used for counting. They can be used for diameter sensing. Remember, we discussed the formula for the range of the ultrasonic sensor, and as this film or this roll is being used up, the range of the sensor will start to increase, and we can use this mathematical calculation to determine whether the diameter is being decreased or increased. They can be used to detect the height or the object or the contour depending on the application. So that's about it for the proximity sensor. In the next lecture, we are going to discuss other type of instruments and the sensor used in an industrial environment. And particularly, we are going to see the temperature measurement. What are the sensors? What is the difference between transducer, sensor, and transmitter? And how they are coupled together to form a temperature measurement and controlling system. So, see you in the next one.